Hello everyone. In this video, I will discuss about the how to determine the stresses and deformations in the compound bars. This is I will explain with one example problem. Let's see the problem. A steel rod of cross-sectional area 2000 mm square and two brass rods each of cross-sectional area of 1200 mm square together support a load of 500 kilonewtons as shown in figure. Find the stresses in the rods. Take E value for steel is 2 into 10 to the power 5 Newton per mm square and E value for the brass is 1 into 10 to the power 5 Newton per mm square. So now see the solution. So first we have to use the, let us use suffix B for the brass and suffix S for the steel. And we have to observe the given data. In the given data, so here it is given that one the cross-sectional area of the steel, that is the 2000 mm square. So let us consider AS. AS means cross-sectional area of the steel rod, which is equal to 2000 mm square. And from the diagram you have to observe that one the length of the steel rod, which is equal to 300 plus 100, that is the 400 mm. And one more thing you have to observe that one the, so cross-sectional area of the each of brass rod is equal to the 1200 mm square. So cross-sectional area of the single brass rod equal to the 1200 mm square. Here we are having the two brass rods. So total area of the brass, it will become the 2 into 1200 mm square. So here in the data is given that one the cross-sectional area of the single bar, that is equal to the 1200 mm square, and the length of the brass, that is you have to observe from the diagram, that is the 300 mm. So and we know that during the solving of the compound bars we have to use the two relations. First one is the from the condition of equilibrium. So condition of equilibrium saying that from the applying load which should be equal to the, so load on the steel rod plus load on the brass rod. So that is the, let us consider PS is the load on the steel rod and PB we are considering the load on the brass rod, which is equal to the capital P is applying load. So here applying load is the 500 kilonewtons. So from the condition of equilibrium saying that one the applying load should be equal to the load applying on the steel rod plus load on the brass rod, which is equal to the P equal to PS plus PB. And we know that one the, so we can be say that one the, so force or maybe load which is equal to the stress into the cross sectional area. So PS will become the sigma S AS, which means so load on the steel rod equal to the stresses in the steel rod into cross sectional area of the steel rod, which is equal to the sigma S AS. Similarly, PB, which is equal to the sigma B AB, which means load on the brass rod equal to the stresses on the brass rod into cross sectional area of the brass rod. So equal to the capital P, that is the applying load. So then we have to substitute the values, that is the AS and AB and P. So which is given in the data. So cross sectional area of the steel, which is equal to the 2000. Similarly, total cross sectional area of the brass rod, which is equal to the 2 into 1200. In the data is given that on the only area of the single brass rod, but here we are having the two brass rods. So which is equal to the 2 into 1200 mm square, that is it 2 into 1200 sigma B equal to the total applying load, that is the, here we have to observe 500 kilonewtons, which is nothing but 500 into 10 cube. So this equation will become the 2000 sigma S plus 2 into 1200, which is equal to 2400 sigma B equal to the 500 into 10 cube. So let us consider this is the equation 1, and we know that one the another equation is equation of compactability. From the equation of compactability is saying that one the deformation in the steel rod equal to the deformation in the brass rod. Let us consider delta S equal to the deformation in the steel rod, and delta B let us consider the deformation in the brass rod. So from the equation of compactability, sigma S equal to the sigma B. We know that one the deformation equation we know So deformation delta equal to PL by AE. So here deformation of the steel, that is the sigma S equal to PS AS by AS ES equal to the sigma B equal to the PB LB by AB EB. So from the given, so one more thing. So we know that when the PS by AS, so load by area, we have to say that only, that is the stress, that is the sigma. So PS by AS equal to sigma S, and LS by ES equal to the, similarly here also PB by AB, we have to say that one the sigma B. So load by area, which is equal to the stress. So that is the sigma B, sigma B LB divided by the EB. And we know that from the LS and LB, we know from the diagram we have to observe LS value and the LB values, and the ES and EB value is given in the data, that is the E value for the steel also given, E value for the brass also given. Then these values have to substitute in this equation, then we will get the relationship between the sigma S and the sigma B, that is the sigma S equal to the 1.5 into the sigma B. Then we have to substitute the sigma S value in the equation 1. So then we will get the sigma B value. So equation 1 is saying that one 2000 sigma S plus 2400 sigma B equal to the 500 into 10 cube. So here, and also we got the relationship between the sigma S and sigma B from the compactability equation, that is sigma S equal to 1.5 sigma B. Now we have to substitute sigma S value in this equation, then it will become 2000 into 1.5 sigma B plus 2400 sigma B. So this is the 2000 into the sigma S plus sigma S, in the place of the sigma S we have to write down 1.5 sigma B. So 2000 into 1.5 sigma B plus 2400 sigma B equal to 500 into 10 cube. So from this one, so we have to solve. So if you solve this one, we will get the sigma B value is the 92.59. So we know that one the relationship between the sigma S and the sigma B. Here we have to substitute the sigma B value. We will get the sigma S equal to the 138.89 Newton per mm square. So this is the solution for the given problem. So thank you.